Hello everyone. Hope you all are fit and fine. Dear students, we know that due to corona pandemic situation, the whole country has locked down. The country is struggling with schools, teachers and lack of education. Most of schools of the country have started online classes. You must take advantage of this opportunity. We, on behalf of Onic Edu Center, E-Class platforms, welcome you to all again. Today, I have to discuss through my PPT slides whatever we have to cover our online class series. Look at the here. What are the contents we still cover? The chapter of electricity. Now, first is what is electricity. As you know that electricity is nothing but of source of energy. After that we learn what is charge. What is charge we learn the flow of electrons. A particular circuit is nothing but of electric charge. So charge is the inherent property of matter that feels force of attraction out, repulsions due to excess or deficiency of electrons. We know that it can divide into two parts. One is positive charge, which is called proton, and another is negative charge, is called electrons. And what you learn, what is the unit of electric charge? That is coulomb, and it's denoted with the alphabetical letter word of capital C. Here few examples are here given here. Let us example the diagram here. When electrons rub into the ebonite rods, another few examples are there that when the same charges, positive and positive charge or maybe negative charge, are always repel each other, and opposite charges are always attract each other. That means same charges are always repel each other and opposite charges are always attract each other. After that, we learn what are the properties of electric charges. The total charge of the universe is conserved, that is nothing but a constant. Like charges attract each other and unlike charges repel each other. Charges are additive in nature. Charges are always quantized. The first numerical formula we learn, that is Q, that is nothing but of electric charge, is equal to number of electrons, that is Ne, where Q is equal to charge, N is equal to number of electrons flow a particular circuits, and E is equal to charges of electron, that is nothing but of how much? 1.6 into 10 to the power minus 19 coulomb. I hope you remember that charges negative sign we are not using in numerical maths. We are using as a 1.6 into 10 to the minus 19 coulomb. Negative charge denoted that it is a negative charge, and charge is always relatively constant term. After that we learn method of charging, that conductor and the insulator. What is conductor we learn? Conductor means those substances current can flow, this is called conductor. And what is called insulator? Those substances current cannot flow, that is called insulator. After that we learn what is electricity. What is electricity? As simple as that, electricity is a form of energy that can be easily changed to many other forms, that is nothing but of flow of electric charges. It can also define as the flow of electrons in a circuit. After that we learn what is electric current. What is electric current? Electric current is nothing but of flow of electric charges. It is a rate of flow of electric charge or electrons through a conductor. Electric current denoted with the letter of capital I, that is I is equal to Q upon T. What is Q? Q is nothing but of electric charges and T is time taken. Instead of Q we can apply a numerical formula Ne upon T, where I stand for current. As you remember that electric current, SI unit of electric current is ampere. Ampere, the famous physician, Andrew Mary Ampere, as the honor of his name, the SI unit of electric current is ampere, and it is a scalar quantity. But I remember it, I mention you that electric current, we already said this scalar quantity, but it's as like a tensor quantity. And the instrument which measures the electric current, its name is ammeter. and its direction always opposite to the flow of the electrons. Look at the picture here, opposite the flow of the electrons. That means positive terminals to the negative terminals, and electron is negative terminals to the positive terminals. After that we learn what is electric field. What is electric field? Electric field is a three-dimensional space around a charge in which the force of attraction or repulsion can be felt. Electric field intensity, that means it is the force of experience by unit positive charge when placed in a magnetic field. It is denoted by capital of letter E. And what is the SI unit of electric field? That is nothing but of Newton per Coulomb, and it's always a vector quantity y. It has a particular direction. After that we learn electric potential and the potential differences. What is electric potential? As you remember that I have to mention, let us imaginations, there are two buckets of water when there is no difference of voltage. That is, it is the amount of work done in bringing a unit positive charge from infinity to a given particular point. Remember, infinity to a given point in electric field. And what electric potential is a scalar quantity, and what is the unit of electric potential? That is nothing but of volt. So V is equal to W upon by electric charges. And what is the electric potential difference? It is the amount of work done in bringing any positive charge from one point to another point, right, in electric field. That means there is a difference of changes of voltage. That means nothing but of potential difference. After that we learn the combinations of electric current and the electric potential difference. The famous law in the year of approx 1826, a German physician, Georg Siemens Ohm, studied to make a relationship between the electric current and the potential difference. The law name is Ohm's law. So what is Ohm's law? It was stated by the Georg Siemens Ohm approx in the year of 1826. He stated that at constant physical condition like temperature are kept constant, then the amount of current flowing through the conductor is directly proportional to the potential difference across its end. That means V is proportional to the I. That means voltage is direct relationship with the electric current. That means potential difference V is equal to, we are applying here a constant term, that is nothing but of R. R is what? Resistance. What is resistance? Resistance is external by opposite force applied on a electric current. So R is equal to V upon by I. And what is the unit of resistance? That is omega. Nothing but of ohm is a Greek letter omega. And what is ohmic conductor? Ohmic conductor nothing but of which follow the VI graphs. That means when voltage means potential difference and the current are direct relationship, a straight line graph. Look at here the pictures. These are ohmic conductor which follow the obey the rules of Ohm's law. These are called ohmic conductor, and the graph which not obey but not follow the Ohm's law, these are called non-ohmic conductor. After that we learn the concept of resistance and the resistivity. Now what is resistance? As I told, it is defined in hindrance the flow of current, means it try to always oppose the flow of electric current. It is the ratio of potential difference to the current, that is R is equal to V upon I. Its SI unit is volt per ampere, that is nothing but of ohm, is denoted with the Greek letter words omega. That look at here, reciprocal of resistance is called conductance or is called mho, is denoted with mh mho or else conductance, that is unit is ohm to the power minus 1. When there is a high resistance, that is a low current. When there is a low resistance, that is a high current. That's resistance and the current always inversely relationship each other. After that we learn what are the factors affecting of resistance. First of all, resistance is directly proportional to the length of a wire. Number 2, resistance is inversely proportional to the area of the cross section of conductor. Look at the diagram here. Here rho means when we apply a constant proportionality symbol, that is name is resistivity, the symbol name is rho, or say specific resistance. So R is equal to resistivity rho with the multiple of L upon A, where constant rho is the specific resistance of the conductor. Now what is called specific resistance? Specific resistance is the resistance of a conductor of unit length and unit cross-sectional area, that is rho is equal to R A upon L. L means length of a wire. And what is the unit of specific resistance or resistivity? That is ohm meter, right? Here I mention here some few resistivity tables of different materials, like let us example of silver, let us example of copper, then gold, aluminium, tungsten. Another thing, whenever we are using the filament in tungsten. Why? Because tungsten is a working and the melting temperature of tungsten approx 3380 degrees Celsius. And there are types of resistance. Number one, fixed resistance. Another is variable resistance. Now what is fixed resistance? Their value does not change under constant physical conditions. They are set a particular value. And what is called variable resistance? Their resistance can be easily changed by changing area of cross section and the length. Variable resistance also called nothing but of rheostat. After that we learn electric circuit and its components. What is electric circuit? As you remember that there are two kinds of circuit. One is open circuit, another is closed circuit. A closed path in which electric current can flow is called an electric circuit. Open circuit when there is no supply of current flow in a particular circuit, and the closed circuit when the current flow continuously a particular circuits. Here few diagrams are here. The symbols, electric circuit symbols. Say example of an electric cell, a battery, plug key, a switch open, where different of electric circuit symbols are here. After that you go through it, that measuring devices. We know that ammeter, look at here the picture ammeter. It must connected in a series connections and it's always at low resistance. An ammeter measurement the electric current. Look at the picture here of voltmeter. Voltmeter must always connect in parallel to the circuit, and its positive sides voltmeter is connected to the positive terminals of the cell and the vice versa. That means voltmeter is a high resistance and always connected in parallel connections, and its measurement the electric potential differences. After that we learn combination of resistance. There are two kind of combination of resistance are there. One is series combination and another is parallel combination. What is series connection? By resistance in series, when two or more resistors are connected end to end continuously, they said to be are connected in series. Means we know that in resist connections R is equal to, we learn R1 plus R2 plus R3. That means when a number of resistors connected in series are joined to the terminal or a battery, then its resistance has a different potential difference across its end, which depends on the value of resistance, but the total potential difference across all the ends of all the resistors in series is always should be equal. Look at the picture here, look at the figure here. We know that V is potential difference is equal to V1, V2 and V3, and here I is a constant. So we know that with applying Ohm's law, V is equal to I dot R. So V1 is equal to, as we know that current should be constant here, I the multiple of R1, V2 is equal to I the multiple of R2, V3 is equal to I times of R3. So substituting the value of 1, 2, 3, we finally got the answer RS, the total effective resistance in series connection, that is R1 plus R2 plus R3. And in parallel connection, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. After this much we learn. I am just sharing you some few PPT slides, whatever I discussed till now. Right, you just go through it. And here some few question answer of NCERT books. Let us have first questions. What does an electric circuit mean? If you go through NCERT books, you have to find out what does an electric circuit means. I am sharing with some few question answer also. What does an electric circuit mean? First of all, electric circuit, a continuous and closed path of electric current, is called an electric circuit. Electric circuit consists of electric devices sources of electricity and wires that are connected with the help of a switch, and it can divide in two parts. One is open circuit and another is closed circuit. When open circuit means there is no supply of current a particular circuit, and what is closed circuit? When the flow of current in a particular circuit. Next, question number 2, define the unit of current. We know very easily, it's very easy. Current means nothing but a flow of electric charges in a particular circuit, and the unit of current is ampere. It's a famous physician, Andrew Ampere is the honor of his name. The unit of current is ampere. So what is 1 ampere? 1 ampere is equal to 1 coulomb per second. After that, we have to solve first numerical. They calculate the number of electrons constituting 1 coulomb charge. I will remember that electron charges, we are applying a numerical formula, that is 1.6 with the multiple of 10 to the power minus 19 coulomb, and it's contain of charges of 1 electron. So finally you got the answer, that is n is equal to 6.25, the multiple of 10 to the power 18 number of electrons can flow of 1 coulomb constituting charges. After that, name a device that helps to maintain a potential difference across a conductor. So what is a device? The name is, name a device that helps to maintain a potential difference across a conductor. What is the name of device? Any source of electric like battery, cell, power supplies, etc. help to maintain a potential difference across a conductor. So why? Because electric battery is nothing but of storage of energy, and who have to carry this energy? Nothing but of electrons. Next question. What is meant by saying that the potential difference between 2 points is 1 volt? That means, what is potential difference? Potential difference is denoted with the alphabetical letter of V. V is equal to W upon by Q. What is W? Work done upon by electric charges. So what you can say that what volt is equal to, if 1 joule of work is required to move a charge of amount 1 coulomb from one point to another, then it is said that the potential difference between the 2 points is 1 volt. Next question please. How much energy is given to each coulomb of charge passing through a 6 volt battery? We know that potential difference is equal to work done upon by charges. So work done is equal to potential difference with the multiple of charge. Here charge given 1 coulomb, potential difference given 6 volt. So work done here 6, that multiple of 1, that is 6 joule. Joule is the unit of work. Next question. On what factors does the resistance of a conductor depends? As I mentioned, length of a conductor, that is R is directly relationship, that is R is proportional to the L. Cross sectional area of a conductor, that is R is inversely relationship 1 upon A, and the material of conductor, temperature of the conductor. These are the 4 factors resistance of a conductor depend. Will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source, and why? As you remember, I mentioned you that current will flow more easily in thick wire instead of thin wire. Why? Because the resistance of a conductor is inversely proportional to its area of the cross section. If thicker the wire, less its resistance, and hence more easily the current can flows. Next question. As the resistance of electrical component remains constant while the potential difference across the two ends of a component decreases to half of its former values, what change will occur in the current through it? I'm going to solve these problems. According to the Ohm's law, we know that potential difference V is equal to I times of R. That means I is equal to V upon R. What is R? R nothing but of resistance. Now potential difference is decrease how much? Half. That is V dash, new potential difference will come V upon by 2. Resistance remain constant here. So new current I dash is equal to V dash by R. So after numerical value, find out that when potential difference decrease, current also decreases. Why? As per the Ohm's law, potential difference always direct relationship with the electric current. Next question. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? As you know that the resistivity of an alloy is higher than a pure metal. That's why nowadays we are using a nichrome alloys instead of a pure metal. Moreover, at higher temperature, the alloys do not melt readily instead of pure metal. Hence, the coil of heating appliances such electric toasters, electric irons are made of an alloy rather than a pure metal. That's why nowadays, whenever you look at that electric irons, the wire we are using is made up of an alloy name is nichrome. Next diagram, draw a systematic diagram of a circuit constituting of a battery of 3 cells. One is 2 volt each and 5 ohm resistor and 8 ohm resistor and 12 ohm resistor and a plug key. All are connected in a series connection. We know that whenever resistance are connected in a series connection, total effective resistance Rs is equal to R1 plus R2 plus R3. So 3 cells of a potential difference 2 volt each connected in series. Therefore, the potential difference of the battery will be 2 volt plus 2 volt plus 2 volt. That how much? 6 volt. The following circuit diagram shows the 3 resistors of 5 ohm, 8 ohm and 12 ohm respectively connected in series and a battery of potential 6 volt and a plug key which close means the current in flowing a particular circuit. Next last question. Redraw the circuit of equation 1 putting in an ammeter to measure the current through the resistors and a voltmeter to measure potential difference across the 12 ohm resistor. What would be the reading in the ammeter and the voltmeter? Look at the diagram here. An ammeter, we know that always measurement the electric current and the voltmeter measurement the electric potential difference. From the figure, the resistors are connected in series. Ohm's law can be used to obtain the reading ammeter and voltmeter. According to Ohm's law, what we learn, V is equal to I times of R, where V is equal to potential difference. How much given here? 6 volt. Current flowing through the circuit upon by resistors. How much is given here? I. Resistance of circuit are given here how much? 5 plus 8 and 12. All are in series connection. That's why R1 plus R2 plus R3. How much is come? Total resistance 25 ohm. So current I is equal to V upon by R. Finally, how much current we got? Answer that is 0.24 ampere. Potential difference across 12 ohm resistor is equal to how much? V1 given here. Current flowing through the 12 ohm resistor I, how much find out? 0.24 ampere. Therefore, with the applying of Ohm's law, we obtain the value of V1 is equal to I times of R, that is total potential difference V1. How much we got it? Answer 2.88 volt. Therefore, the reading of the ammeter will be 0.24 ampere and the reading of the voltmeter will be 2.88 volt. So here I am sharing you few question answers, my PPT explanations. I hope you will go through the question answers and try to learn this question answer and make a note down in your copy.